angle QPR is 45 degree. To verify that, we need to find the value of angle QPR. It would be easier if we draw visually how the triangle PQR looks like, the length of the sides and the angle between the sides. Then it would be easier to evaluate. This is what we are drawing as triangle PQR. This is PQR. According to the question, angle PQR is 30 degree. This is angle PQR, which is 30 degree. And angle PQ and QR have length 10 root 3 and 10. PQ is 10 root 3 and QR has length 10. We have to find the value of angle QPR. Let's assume that the value is theta. Then we have angle PRQ as 150 degree minus theta, because the sum of the angles of a triangle is 180 degree. Based on this theory, to know the value of angle QPR, we have to use the sine formula for the triangle, and the formula is as follows. If we have a triangle which has sides A, B, C and has angles capital A, capital B and capital C, then the sine formula states that A by sine A is equal to B by sine B is equal to C by sine of C. Applying that same formula to this triangle, we get the side PQ divided by angle PRQ, the sine of angle PRQ is equal to QR divided by sine of angle QPR, which is basically implies PQ is of length 10 root 3 and angle PRQ is taken as 150 minus theta. This is sine of 150 minus theta is equal to QR is 10 divided by sine of angle QPR, which is theta. So it's sine of theta. That implies root 3 sine theta is equal to sine of 150 minus theta. Expanding sine of 150 minus theta by sine rule, by sine of A minus B rule, we have sine of 150 minus theta is sine of 150 degree into cos theta minus cos of 150 degree into sine theta, and the LHS is the same, which is root 3 sine theta. We have to put the values of sine 150 degree and cos 150 degree in this problem. We have sine 150 degree is equal to sine of 180 minus 30 degree, which is nothing but sine of 30 degree, which is equal to half. And we have cos of 150 degree is equal to cos of 180 minus 30 degree is equal to minus cos 30 degree, which is equal to minus root 3 by 2. Using and putting the value in the equation, we get root 3 sine theta is equal to half into cos theta minus of minus root 3 by 2 into sine theta. That implies root 3 sine theta. This is a normal question and can be solved by just normal addition, multiplication. Cos theta by 2 plus root 3 by 2 sine theta. That implies the equation finally is root 3 by 2 sine theta is equal to cos theta by 2. That implies tan theta is equal to 1 by root 3 is equal to 30 degree. That implies 30 degree is equal to theta. Tan theta is equal to 1 by root 3 means theta is equal to 30 degree. That implies angle QPR is equal to 30 degree. That implies the statement A is false. Now we evaluate the second option, which is the area of the triangle. From that we can easily find the value of angle QRP. We have the triangle as PQR and we have PQR as 30 degree, PQ as 10 root 3 and the length of QR is 10. We found that the value of theta, which is equal to angle QPR, is 30 degree. That implies angle of PRQ is 150 minus theta, which is 120 degree. So the second part of the option B, which says angle of QRP is 120 degree, is correct. We see that angle QPR, which is the green shaded angle, and angle PQR, which is the yellow shaded angle, are equal. That implies triangle PQR is a isosceles triangle and the value of the length of PR is 10 because sides opposite to equal angles are equal. To find the area of triangle PQR, we will use area of triangle PQR is equal to half AB sine theta. It's basically the half into the product of any two sides into the sine of theta, where theta is the angle between A and B. If we take A as PR and B as PQ, then we have half of 10 into B as 10 root 3 into sine of 30 degree, which is the angle between the sides, is equal to half of 10 root 3 into 10 into sine 30 degree is half. Then we have this as 25 root 3, which is true in the given option. That implies option B is true. Now we evaluate the third option, which says the radius of the inner circle of the triangle PQR is 10 root 3 minus 15. To evaluate the inner circle, we have the inner circle of the triangle R is equal to del by S, where del is equal to the area of the triangle and S is equal to the semi-perimeter. Here we have, if you have a triangle ABC with sides as ABC, we have semi-perimeter as A plus B plus C by 2. We'll write this in the formula section. That implies the inner circle, the value of the inner circle is del, which is 25 root 3, which we evaluated in option B, divided by the semi-perimeter, which is 10 root 3 plus 10 plus 10 divided by 2, which is equal to 25 root 3 divided by, this is 20 plus 10 root 3 by 2, which is equal to 25 root 3 divided by 10 plus 5 root 3. Now we see that in option C, the radius of the inner circle of the triangle PQR is given as 10 root 3 minus 15. So we do not need a denominator term here. We need to rationalize the denominator. For that, we will multiply and divide by a number so that we can rationalize the denominator. For rationalizing the denominator, we have R is equal to 25 root 3 divided by 10 plus 5 root 3. We multiply the denominator by 10 minus 5 root 3 and we multiply the numerator by the same, which is 10 minus 5 root 3. That implies 25 root 3 into 10 minus 5 root 3 divided by, we have this as A plus B into A minus B, which is A square minus B square, which is equal to 10 square minus 5 root 3 square, which is equal to 100 minus 25 into 3, 75 is equal to 25. That implies this is equal to 25. That implies R is equal to root 3 into 10 minus 5 root 3 is equal to 10 root 3 minus 5 3s are 15, which is matching with the option C given. That implies C is true. Now we have to find the area of the circumcircle of the triangle PQR, which is the fourth option. The area of the circumcircle of the triangle PQR is 100 pi. To evaluate that, we use the formula to find the circumcircle of the triangle. The circumcircle capital R is equal to ABC by 4 del, where ABC is the length of the sides divided by 4 into del. Del is the area of the triangle. We idealize this for ABC and we have this as, for this triangle we have R, capital R, which is the circumcircle of the triangle, as ABC by 4 del. Applying the formula for the given triangle, we have R is equal to, we have one side as 10 root 3, other as 10 and another as 10 divided by 4 into del is 25 root 3 as evaluated in the previous option. That implies we have R as 10, which is the circumradius. Now to find the area of the circumcircle of the triangle, area of circumcircle is equal to pi of capital R square, where R is the circumradius, is equal to pi into 10 square is equal to 100 pi. That implies option D is also true. So the final answer of the question is B, C, D is true.